This video is going to look at the electrophilic substitution of benzene. First thing to remember is benzene undergoes substitution, not addition reactions, like most compounds with double bonds. A strong electrophile is needed, such as nitronium. I want to begin by looking a little bit more at how nitronium is made. We begin with the reaction of sulfuric acid and nitric acid. They're both strong acids. However, if we follow the motion of protons, we can see that sulfuric is slightly stronger and donates a proton to the nitric acid. That then forms a complex that has H2NO3 with a positive charge. That's not particularly stable, and it immediately breaks down into water and our nitronium ion. If you look at the electron dot structure of nitronium, we can see that it has 16 electrons, or 8 pairs, which would arrange themselves as follows. If we look at the nitrogen in the center, it has 2 regions around it, hence it would form a linear molecule. Now let's look at the reaction of this nitronium with benzene. I'm going to draw benzene here showing one of the carbons, so the other 5 aren't being shown. I'm going to focus on just one of the hydrogens, the one that's closest to our nitronium. Our electrons begin by studying the delocalized electrons that are in the center of our benzene ring. There are 6 delocalized electrons. 2 of them go and bond with our nitronium ion. This then forms a complex which no longer has a complete delocalized ring in it. The hydrogen solves this by donating its pair of electrons to complete the ring, and now that hydrogen leaves with a positive charge. If we look at the overall reaction, benzene plus nitric acid form nitrobenzene and water. The conditions needed for the reaction are a sulfuric acid catalyst. Remember that nitric acid and sulfuric acid are required to form our nitronium ion. I want to take this time to summarize a little of the differences between our electrophiles and nucleophiles that we've come across in this unit. First of all, their definitions. Electrophiles mean electron liking or negative liking. They're capable of accepting a pair of electrons. Nucleophiles, thinking of the nucleus as positive, are positive liking and capable of donating pairs of electrons. Now, we've seen before this concept of donating pairs of electrons and accepting pairs of electrons with Lewis acids and bases. An electrophile is a Lewis acid, as are carbocations, which we've come across in electrophilic addition reactions. Nucleophiles are Lewis bases, capable of donating pairs of electrons, as are ligands, which can form coordination bonds with metal ions. If we look at the reactions, electrophiles are involved in addition reactions with unsaturated hydrocarbons, such as alkenes and alkynes. Electrophiles are also used in substitution reactions with the benzene ring. Nucleophiles also react by substitution, but with halogenoalkanes. You'll recall things like SN1 and SN2 substitution. Examples of electrophiles would include things like our nitronium ion or the methyl radical. Polar compounds are also good electrophiles. In the case of nucleophiles, we have hydroxide and cyanide, and neutral compounds such as ammonia or water. Give us a like if you found this useful, and questions are always welcome.